All right, we're back. We are Game 2005, that's Game Physics, in the fall 2018 semester at George Brown. And we're week 13, part 3 of our broadcast, Simple Collision Detection with SDL continued. In the previous video, what we did was we talked about how to make a little island that we can collide with. And now what we're going to do is we're going to make a collision manager class that's going to help us. It's going to be a little bit of a utility class that's going to help us detect collisions between the island and the player. All right, so how do we do this? So again, just like we did before, I'm going to go to my Solution Explorer. And this time, let's try something different. Okay, so I'm going to go here to my header files, right-click. I'm going to add, and this time I'm going to add a new class. Let's see how this works. Okay. Again, this is a bit of wizardry. But remember, when I do a new class, is this going to go in the right place? By default, will this class go in the right place if I did a new class? The good thing about it is it says virtual destructor, and I can do all this other stuff with it. On the bad side, it doesn't go in the right place unless I tell it to where it's going to be. So I'm going to need to be more directive here when I make this. So here's my class name. It's going to be Collision Manager. Okay, Collision Manager. Then I'm going to click these ellipses. So this, I'm going to go here and click where I'm going to go. And this is a really bad thing, okay? So what this does is it says, where do you want your collision manager.h to be? Now, I know that where it is, I'm in courses under Game 2005. And this is where the file name that I'm going to be using inside of my Friday section, SDL template SRC. Now, that's just me. This is where I want this collision manager to be. I'm going to click Open. And it says, hey, I can't find this file. It doesn't exist, because that's what this thing is doing. It's looking for a new file to include. However, if I don't do this, it's going to put this in the wrong space, because this is the way the template's configured for us. Okay, I can fix this later. Now, let's just do it and fix it, because sometimes this is what's going to happen on your test. You're going to try and add stuff in, and just like some of us had errors today, you put your classes in the wrong spot. How do I move them? I kind of showed you this last time. Let's just do it, and then I'll move them in the right spots, okay? So let's just do this. Notice there's no base class, and I don't have any accessors or anything like that. I'm just going to press OK. The great thing about doing this, the good thing about it is it creates your collision manager class and your collision manager constructor and destructor, as well as your CPP file with the stubs. And that's all it's good for. Other than this, it's bad because, and I'm just going to close these down for a second. If you look at your, if I look at my template now, if I go into open folder in File Explorer, you can see that it's put my collision manager.cpp and my collision manager.h in the wrong spot for me. I don't want it there. I want it inside of my source files, right? So what I need to do is inside of my Solution Explorer, I'm going to remove my collision manager here. So I'm going to go right click and then click remove and remove here, not delete. And the same thing goes with here, collision manager, remove and remove. And then back inside my operating system files, I'm going to go into my template. I'm going to grab these two files. So in collision, and this is inside my template. This is the exact location where they are. Grab these two files, cut them. So Control X, sorry. Go back to my template, go into SRC, and then Control V for paste. And now effectively I've moved them into the right location. All right? And again, most of the times you're not going to need to do this too much, but just in case it happens on the test, then you know how to fix it. Okay? Okay, now I need to include them back in. So in my header files, I'm going to add an existing item. I'm going to specify that inside the SRC folder, I'm going to add collision manager.h. There it is. And the same thing with my source files, add existing item, right? Collision manager.cpp. And now I'm good to go again. Okay, so I did that just to show you there's different ways of doing it. A couple things that are missing in my collision manager.h, right? Notice we didn't put in the if not defined and then define. So again, just to be lazy, I'm going to go into my island.h and grab these two files, these two lines, and go into my collision manager.h and put them at the top. Okay, so, but instead of island, of course, they're going to be called collision manager. Yay. So I'm defining my new collision manager only once. And the same thing goes with my endif. So if you look at my player on the bottom, there's a little endif line. I'm going to grab this, going to go here, and without typing it, I'm going to go to collisionmanager.h and put that in as well. And then, of course, change the bottom part to say collision manager. Okay, now this prevents cyclic references, and that's how we do it. So we've got my collision manager.h, my constructor, my destructor, but I'm never going to instantiate my object. I'm going to use my collision manager class as a container class or a utility class for any kind of collisions and any kind of calculations in the future. So what I want to do is I want to put these two things in my private area. Okay, so collision manager, the destructor and constructor, you won't be able to instantiate a type of collision manager after this, when I do this. However, I do want to declare a new static function called check. I want to do a collision manager.check, almost like a collision check. That's what it is, right? And I want to check between two game objects. In order for me to check between two game objects, I've got to include a reference to the game object superclass. So I'm going to go here. I'm going to include a new reference to the game object superclass. There it is. And then what I'm going to say here is in my check function, I want to define two objects I'm taking in. One is a game object reference to object one. Remember that my objects are all pointers to game objects, and another pointer to object two. Okay, so that's what I want. I want object one and object two. And my check is going to return a Boolean. Did I collide or not? Okay. I may or may not use the Boolean later on. Okay. So that is my static, so public static, which makes this check function, if you think about it, this check function is just a utility function that I'm going to make. Further to this, even though this is called Collision Manager, just to be a little bit different with what I've done in the past, notice that when I use my texture manager or my game.h, at the bottom, I've defined a type definition, right, for the object, right? So type def game, the game, right? Let's make it easier for me to do this thing with my Collision Manager. So I'm going to say at the bottom, type def, and then we're going to say Collision Manager. We're just going to call it collision. So if I can actually spell type def. There we go. So now all I have to do is say collision.check, a collision check. Right? But we're using the Collision Manager to do that. Okay? Does that make sense? All right. We have to define what the collision check is. So I'm going to go right-click here, and I'm going to go to create my definition check in collision manager.cdp. There it is. Here's my collision manager.check. It's going to return false by default. And what I want to do here is in my collision manager.cpp, I want to define what this collision check is. Okay, a couple things. I want to check the distance. The way I want to do collisions here, I want to do simple collisions. For your assignment 3, I want you to have different collision methods. The one I'm going to show you here is a very simple half-circle collision, which we haven't really kind of done before. And in order for me to do that, I need the distance. So for me to get this distance, what I want the Collision Manager to do is use a new library called GTX core, all right? So if I go back to collisionmanager.h, I'm going to include a library called GLM GTX core, and actually it's actually, if I'm not wrong, it's core.hpp, but let me see what that is. Is it core? I'll look it up. So if I want to do distance checking, so I want to go GLM distance squared is what I want to look for. Oh, GTX norm. Yeah, not core, norm. So it's GTX / norm.hpp. That's the one I want. Okay, that's part of our GLM library. It's already included in your code. I've already included all these things in your code. And the GLX norm library actually does some extra functions, like a distance check. By the way, this distance check we're going to replace next week, because right now it's using square root. And next week, we're not going to use square root. We're going to use squared distance, which is better. Okay? All right, so here's norm.hvp. And if I look at my collision manager.cpp now, what I want to do is I want to do the following. In my game, I'm taking two game objects, game object 1 and game object 2, right? And I want to get positions for these two game objects. So I'm going to say glm vec2 position 1 is equal to object 1 dot get position, right? And glm vec2 position 2 is equal to object 2 and then get position. What I'm doing here is I'm just making you know, some smaller references to position 1 and position 2. Okay? Now what I want to do is I want to say if the distance, glm distance, right, of position 1 and position 2 is less than half the height of the object. I don't have that. Let's do that. So I'll say a new integer that is called half heights, which is going to equal to the height of object 1 and the height of object 2 added together and divided by 2, right? So we're going to say object 1 dot get height plus object 2 get height, right? And then multiply this whole thing by 0.5, which is going to give us the half heights, combined half heights. We're going to say if it's less than half heights, if that's true, then I have a collision, yeah? Because it's that half the height of the object is like half a radius. The reason I'm using half heights is because it's coming from above. My objects are coming, it's a downward scroller object, right? I don't have a right, if something was coming left and right, I would maybe use half widths. And if it was something that was free scrolling from anywhere else, maybe I'd use a radius, right? But here I can probably get away with using half heights and be okay with it. Okay, that's number 1. And if that's true, what I want to do is I want to use Iostream. So let's just use a core library. We're going to use include Iostream. Okay, and Iostream is going to give us cout and cin. I'm just going to use the cout function, so standard cout. I want to pass in a little message that says in my console, that's going to say collision, yay, right? And that's the collision. If this is true, and I'm also going to set this. I'm also going to return true, right? Because if I'm good, I've got a collision, I'm going to return true. Okay, does this make sense? So this is my Boolean static check method. That's what I'm using. And notice that I'm never going to instantiate a type of collision manager. I'm never going to do that. Okay, I'm just going to reference the collision manager as a static functional area, a place where I can use some helper utility functions that are global to my program, if you will. Again, I could have made a singleton, but then I'd have to instantiate my collision manager, and I don't want to do that. There's other ways of doing it. Okay, let's take a look at my game.cpp now. So first of all, in my game.h, I need to include my collision manager. All right, so around here, I'm going to say that I'm going to include my collision manager.h. Now that I've included my collision manager.h, I can detect collisions, right? I can use my check function, if you will, right? That's in my game.h. In my game.cpp, in the update function, underneath where I move and I update the players, right? Here's my update function. I'm going to do a collision check. I'm going to say something like this. Now remember, I renamed my the collision manager as collision. I can do this. So collision check, and I want to check between two game objects. I want to check between m_player and m_p island. Okay, so this is happening every frame. That makes sense? Now notice how I did that, collision check, it makes sense. It's contextual. I'm doing a collision check, right? And I'm using the collision manager to do this. It's a static function. I'm not instantiating an object of type collision manager. I'm just using its static check function to do this. Okay, let's see if this works. So I'm going to run this thing, and let's see what I get when I try and do the collision thing. If everything goes well, I should see one collision every time I run over the island. But of course, it's not going to be this way. Tell me why I'm getting this now. Look at that. I get like a bunch of collisions. Why is that? Right? How come I'm getting a bunch of collisions? Right? Let's try this again. So I'll show you one more time. Right? This is pretty straightforward stuff, guys, but I want you guys to think about it because it's going to affect what you do on your assignment 3. Okay, lots of collisions there. How come more than one collision? How come? Well, because every time I'm colliding, and that means from here, 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 and here, here, here. I can't even say it as fast as that. I'm going to get a bunch of collisions as my plane passes through my island. For every frame that it passes through my island, that means like a bunch of times in a second, right? I'm going to get a bunch of collisions. This is no good, guys. If I do this, that means if I collide with it and try to make a sound, it's going to make a sound like, let's say it was the yay sound. It would make a yay, 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 right? So it would make that sound over and over again for every time it collides. I don't want to do that. If I was getting points for colliding with my island, I would get a bunch of points for colliding with one island. I would increase my points a lot of times. I only want to do it one time. And this goes back to your assignment 3, part 2, which says, hey, I got a rain of bullets happening, but I only want you to collide with the your object and the bullet one time. Right? How do I do that? So yeah, we've done our collision check, great, but we want to know two things. Which object am I colliding with? Am I colliding with the island? Maybe there's an enemy in the future. Maybe I'm using my bullet in my plane. I want to know which object I'm colliding with, number one. Second thing is, I only want to collide once. So how do I do that? So one thing is I want to create a new capability in my GameObject.h, a couple of new capabilities. And this is slightly different than I showed you guys on Tuesday, the people who are with me on Tuesday. So I want to create a new enumeration. Okay, this is kind of interesting. So on enum, it's going to be called GameObjectType. It's my GameObjectType. I'm going to have two game objects I'm going to define. Okay, one of them is going to be called island, and then player, and then number of game objects. This is kind of a trick. Island, player, number of game objects. Number of game objects, what it does is it'll always go to the total number of game objects if I want to count how many game object types I have, right? So island starts off at 0, player starts off at 1, and I can know which one it is, an island or a player. Okay, that's the one thing I want to try and do. So I have this game object type that I'm defining, right? Down in here, I want to define a couple of new variables, right? And I'm going to call them collision variables. Collision variables. So one of them is going to be my is my object colliding? I want to see if it's already colliding. If it's already colliding, I don't want to check, or I don't want to register another collision while the object is still colliding, right? So I'm going to say it's going to be a Boolean, and it's going to be is m underscore is colliding is what the name of the variable is going to be. And the other one is going to return the type, right? So this is something different than what I did on the Tuesday. Like I said, it's going to be of type game object type. And my game object type is, we're going to say m underscore type, right? We can also call it game object type if you really want to, but type is okay. Okay, cool. Well, I want to make getters and setters for these. So there's going to be 4 new things, 4 new methods I'm going to create. And now some people think this is exhaustive. Like, how come you're making all these methods and they just don't do anything but access the instance variables? It's just adhering to the object-oriented principles. That's why. And there's other reasons too. Maybe in the future we'll do multiple things at once. with our getters and setters. Okay, so we need to do two things. So I want to be able to get and set the type and get and set the is colliding thing. So I'm going to say, okay, for my getter, I want to say that it's going to return a Boolean, and it's going to be get is colliding, right? And the other one, for my getter, for my type, I'm going to say it's going to return a game object type. And it's going to say get type. I want to get the type of my game object. That's what it is. And then for my setters, I'm going to say that void set is colliding and void set type. Okay, so those are the four new functions I'm adding into my game object.h. Again, I'm going to go here, and I'm going to create my definition. And I'm going to do the same thing here. So create my definition there. Same thing over here. And finally for type. I'm doing this really slow because I want you guys to catch up to. Those are the kind of getters and setters I made. All right, let's take a look at my GameObject.cpp now and see what I've got. So again, I've got some getters and setters. And if I look at the new getters and setters, I've got a get is colliding and get type. Get is colliding is going to return m underscore is colliding. It's going to return whether it's true or false. And game object type is going to return m underscore type. There we go. That's what it's going to return there, right? M is colliding, m type. And then in our setters, we're going to do the exact opposite thing. We're going to say that m underscore is colliding. This is wrong. I should have passed in some kind of variable here. So going back to my GameObject.cp.h. Okay, so that set is colliding to is the collision. So I'm going to say a Boolean type that is a collision. Yes or no? Right? And then my type is a new type. So game object type, which is the new type, whatever the new type of game object it is. Okay, so I need to do those things, which means I need to modify these signatures here to accommodate that. So set is colliding to a Boolean collision. And this would be collision, right? And this is new type. So this is game object type, right? Which is new type. I'm going to set the m underscore type to the new type. This is all the standard stuff I've done with each of the things, each of my getters and setters. Again, these are convenience functions that access the instance variables, and some people may argue that they're not necessary, but we're using them to adhere to object-oriented standards. Okay, so we're going to move on. Now that I have this information for my collision, for my objects, each object has this stuff, I can go back into my my game.h and my game.cpp, right? And I can detect other types. But where the real work can happen is inside of my collision manager.cpp class, where I can now only detect collisions if the object is not colliding. So instead of my if statement being like this, I can say if, and then I can put an else statement. I can make this false. Okay. And I can say that if my object 1 doesn't collide here, then it returns false. I can do that too. But let's try and make it so that my game object, actually I'll do that here first. I'll say that if I don't collide, so if I fail this check, so if the position of game object 1 and game object 2 aren't within the limits of the half heights, or the radius, if you will, then there will not be a collision. It's going to go here, which means that the object 2, right, set is colliding to false, right? I can set that to false. And in fact, I want to be able to set my is colliding property for each of my default game objects at the beginning when I construct them, right? I want to do this right away. So when I go to my island.h, or island.cpp, I mean, and in my constructor function, which is way up here, I want to set is colliding to false in my constructor function. Okay? And I'm going to do the same thing in my player.cpp, although I don't need it right now. I'm going to set is colliding to false in here as well. So it's not colliding right now. I'm just setting it up so that they start off as not colliding. But in my collision manager.cpp, right now we know that if this is wrong, if I missed my collision check, then it's not colliding. We know that, right? However, what if it's true? It is colliding, right? Then what I want to say is that, okay, cool. I want to do this check. I want to say, okay, check to see if it's within distance. However, also check to see if it's not already colliding. If not, object2 get is colliding, right? So I'm checking if it's not colliding. Then, if it's not colliding, set it to colliding and return true. Otherwise, if it's already colliding, we don't want to do anything here. We just want to keep it as, it's already colliding, so we don't want to return anything. We want to say return false, okay? Although this is a weird thing, this return. We may want to get rid of it later. All right, so again, if object2 is colliding, good. We'll only collide once, and we're going to return true, okay? So let's see if this works in the real world, if I actually make it work. So I'm going to run this thing now. And when I do, we're going to see our little plane and my little island. And if they're colliding, it's only going to show a collision one time. So take a look at this thing, my console. Oh, wait, look. I'm colliding a bunch of times still. What the heck? How come? All right, let's see this. So again, if object2 get is colliding, if it's not colliding, so it's false, and then I collide, but I never set it to colliding. I need to do that here too. So I'm going to say that that's cool, but then I want to object2 set is colliding to true. We never did that, right? So as soon as island2 is colliding, if it's not colliding and it finally collides in here, then set it to true, right? Otherwise, set to false. See if that works. So run it. We should be able to see it only collide once now without any errors. So once. Okay, so we know that that works now. But wouldn't it be nice to know which object is colliding, right? I want to be able to do kind of a switch to know which one it is. Well, I mean, this is good if it's only one object, but what if I want to use the same check function for every object that I know about, right? So I can create something else that's in here. I can create a switch case. I can say switch on object2 type. Here's my get type, right? And by the way, in order for me to do this switch statement, I also have to set type. So on my island.cpp, another thing I need to do is set my type. So set type to, again, this is interesting, game object type, and it's going to be island, right? I need to do that. Game object type island. So I'm actually specifying what type it is. It's an island, right? And I can do the same thing for player. So under the player class, player.cpp, I can say, let's set the type for that. So set type, again, game object type of player. There we go. Now I'm using the set type and get type, or the player type, which is an enumeration, like back to what I did with CPU, this thing right here. This enumeration is a way of checking which one it is. And they're just friendly names for the numbers. So let's say 0 would be island and 1 would be player. But we're never going to remember 0 and 1, so we use nice enumerations, enums, to help us out. All right, so now we can say that, okay, I'm getting the type case if it's if the type, right, is because remember, here's the type right here, right? If the type is island, right? If that's the type, then do something. If the type is, I don't know, player, which is impossible, do something else. And we can have other types, but there's a default case. If it's some other type, let's say some unknown type, we haven't defined, then do something else. So that's kind of our switch statement. This is like doing an if, else if kind of thing. If it's an island, I want to say, hey, it's a collision. I want to move this collision detection thing. I want to say it's collision, but it's a collision with island. That's what I want to say, right? However, if it's some other thing, we don't know what it is, I want to say that it's a collision with unknown type. We don't know what the type is. Unknown type, okay? This is the get type thing. So island and then something else, right? Now we're going to have other types in here. We're going to have island. Next week we're going to have cloud. We're going to have bullets. We're going to have other things you can put in here, okay? So I can define those. I can predefine those things. I'm going to have a couple of other things. If I go back to GameObject.h, I can include other potential types, not just island. And by the way, I can switch the order of this around. It doesn't matter, right? I may want to switch the order around, but who cares? So I've got my island, my player. Let's say I have a cloud, right? I might also have a bullet, right? Maybe an enemy. I could have a bunch of different types, right? But the great thing about number of game object types, or number of types, let's say, I can say number of types, right? Then the great object about this is it counts how many of these are. So 1, 2, 3, 4, 5. It counts the number 5. I can always return. That's a little trick. All right. So if I go back to collisionmanager.cpp, I'm only caring about island, but I could specify anything else. And notice that it defaults to 0. Okay, cool. So I want to see if this works. I want to see if I can get collision with island. And if I do this and I run it, then yay, right? I have my little island. And if I hover over it, it says collision with island now, right? Because it satisfies the requirement. Okay, cool, cool. What if though, I didn't specify, I never did this line on line in my island. Here's my island.cpp. I never did this line. I never specified what type it is. If I just did this, right? How does it work? Will it work? Will it fail? What will it do? Let's take a look. Okay, so I want to do a collision check with my island, and hey, look, collision with unknown type, because I never defined what it is. I don't know what it is, so therefore it's unknown type, right? And this is what I wanted to show you. You can detect which thing you're colliding with by using the type. Okay, and that's part of the game object superclass now. Just for completeness, I know that next week we're going to do some other stuff with my cloud and different things. So let's add those types in here. So I'm going to say, hey, what about if it's a cloud? Then do something. What about if it's a bullet? Then do something else. You know, what about if it's something else? And I keep going. What about if it's a enemy, right? Then, oops. Then do something else, right? And so on, right? Now, none of these do anything. There is no cloud, bullet, or enemy, but I'm putting them in there so you can see how it works. All right, anybody have any questions around this stuff? So guys, a couple things. I've given you basic collision detection with a static collision manager check. That's what it does, right? Next week, I'm going to update the template. I'm going to add, without going through the whole process again of adding a new object, I'm going to add a cloud. I'm going to add a background scrolling ocean. You're going to see it. And I'm also going to get you guys to, I'm going to make a full game with you guys. I'm going to add scores, right? Score values. So like almost like a, you know, lives, how many lives the player has, and how many points the player has. And we're going to make sounds, collision sounds next week, right? I'm also going to talk about different kinds of collision types. We're going to actually have different kinds of collision checks. Right now, this collision check is a very simple collision check, right? And I want to kind of put in place, how do I check for AABB type collisions? What do I do, right? And which one is more accurate? Let's look at some of those different kinds of collision types. Now that we have a collision manager, we can add more stuff to it next week. That's all I wanted to cover today. I'm going to put the final solution up on GitHub, right? You've got part of it. I didn't put it in the switch case, but you'll see that again next week. So I'm going to give you the new template and everything else next week, and you'll have everything. Any questions? Should be fairly straightforward. You should be getting used to the template by now, the SDL stuff, the C++ stuff. It shouldn't be that difficult, and I'm going pretty slow. So, or at least I think I am. Again, professors, we think we're going slow, but maybe we're going too fast for students. But it's recorded, and it's also on GitHub, at least the majority of the stuff. So, guys, thank you so much for coming on Friday morning. I know it's been crazy. I'll see you guys next week on Tuesday. Okay, thanks. I will show it to you.